Hello students, welcome back to the next module of our chapter called electrostatics. Now students, in this particular module, we'll be learning numerical on series and parallel combination of capacitors. Now students, these two type of combinations we have already learned, right? Now let us first revise those concepts and then we'll start with the numerical. Now students, we have already learned that if three capacitors are connected in series, then the equivalent capacity is given by the formula 1 upon Cs, it is equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3, right? And let's say if two capacitors are connected, then the formula is given by 1 upon Cs, it is equal to 1 upon C1 plus 1 upon C2, right? Now, I'll cross multiply this particular terms. So what will I get? I'll get 1 upon Cs, it is equal to C1 plus C2 upon C1 C2. I'll take the reciprocal, then what will I get? I'll get Cs, it is equal to C1 C2 upon C1 plus C2. So students, thus if two capacitors are connected in series, then the equivalent capacity is given by product of two capacities upon sum of two capacities, or I can say product upon sum. Now let us move further. Let's say if three capacitors are connected in parallel, then the equivalent capacity is given by Cp, it is equal to C1 plus C2 plus C3. And let's say if two capacitors are connected in parallel, then Cp, it is equal to C1 plus C2. Now students, all these formulas will be using in the forthcoming numerical, right? Now let us start with the numerical. Now calculate the effective capacity between the points X and Y in the figure given below. So this is our figure. In this case, we are supposed to find capacity between points X and Y. Now let us start with the naming of these capacitors first, or rather let us start with the solution. First of all, we'll name all the capacitors. So here we are having two 4 microfarad capacitors. We'll name them as C1, right? We'll name them as C2, second capacitor is C2. Here we are having 2 microfarad capacitors. We'll name them as C3 and C4, right? So C3 is equal to 2 microfarad. At the same time, C4, it is also equal to 2 microfarad, right? Then we are having 1 microfarad capacitor. We'll name it as C5. And next, we are having 8 microfarad capacitor. We'll name it as C6. And lastly, we are having capacitor with value 32 upon 23 microfarad. We'll name it as C7, right? So this is the situation that we are having right now, right? Now see these two capacitors C1 and C2. How are they connected? They are connected in parallel, right? So therefore, I'll combine these two capacitors. So I can write Cp1, it is equal to C1 plus C2, right? I know value of C1 and C2. What is the value? It is 4 and 4. So therefore, I'll get Cp1, it is equal to 4 plus 4, which is equal to 8 microfarad. Right? Now see these two capacitors, 2 microfarad capacitors. Again, these two capacitors are also connected in parallel. So therefore I can write Cp2, it is equal to C3 plus C4. Right? Now what are the values? Values is 2 microfarad and 2 microfarad. So therefore I'll get Cp2, it is equal to 2 plus 2, which is equal to 4 microfarad. Right? So we have combined C1 and C2, and then we have combined C3 and C4. And then we'll be replacing these capacitors by Cp1 and Cp2, right? Now let us move further. We'll be replacing these capacitors by Cp1 and Cp2, right? So this is the kind of circuit that we'll get after replacing, right? Now let us move further. Now see these capacitors carefully, that is C5 and Cp1. How are they connected? They are connected in series. And when two capacitors are connected in series, effective capacity is given by product upon sum. So therefore I'll get final CS1, it is equal to Cp1 into C5 upon Cp1 plus C5. Now I know values of Cp1 and C5, right? What is value of Cp1? It is 8. What is value of C5? It is 1. So I'll get CS1, it is equal to 8 into 1 upon 8 plus 1. So final answer I'll get 8 upon 9 microfarad, right? So CS1 is 8 upon 9 microfarad. Now see C6 and Cp2, how are they connected? They are also connected in series. So therefore I can write CS2, it is equal to Cp2 into C6 upon Cp2 plus C6, that is product upon sum. Now I know their values, so let us place the value. So I'll get CS2, it is equal to 4 into 8 upon 4 plus 8. So this will become 32 upon 12, right? So we can cancel out over here, right? What we'll get? 4 8s and 4 3s, right? So I'll get finally 8 upon 3, and therefore I can write my CS2, it is nothing but equal to 8 upon 3 microfarad. Now I'll be replacing these two combinations by CS1 and CS2, and I'll get final circuit as this. So this is nothing but my final circuit if I replace these capacitors by CS1 and CS2. Right, now see carefully CS1 and CS2, how are they connected? They are connected in parallel, right? Now let us use the formula for parallel combination. So therefore CP3, it is equal to CS1 plus CS2, right? We know values of CS1 and CS2. What are the values? 8 upon 9 plus 8 upon 3. So it is nothing but equal to, right, CP3, it is equal to 8 upon 9 plus 8 upon 3, right? Now let us take it further. Right, if I rearrange it and if I calculate, I'll get CP3, it is equal to 8 into 3 plus 8 upon 9. So by LCM method we'll get this, right? So students, 8 into 3 is 24, 24 plus 8 is 32. So therefore the value of CP3, it is nothing but equal to 32 upon 9 microfarad, right? Now I'll replace these two capacitors by what? I'll replace it by CP3. So what will I get? I'll get this particular circuit, right? So this is my final circuit looks like. Here C7 and CP3 are connected in series. Now see them, see these two capacitors carefully. These two are connected in series. And again, I'll be using formula for series combination. So what will I get? I can write it as 1 upon CXY, it is equal to 1 upon C7 plus 1 upon CP3. And therefore, what is value of C7? It is 32 by 23. So 1 upon C7 will become 23 by 32. So therefore 1 upon CXY, it is equal to 23 upon 32 plus 9 upon 32. And if I add, I'll get 32 upon 32, and which is nothing but equal to 1. So therefore 1 upon CXY, it is equal to 1, and therefore CXY in this case, it is equal to 1. So the equivalent capacity in case of given circuit, it is equal to 1 microfarad. So students, in this particular module, we have learned numerical which was based on the combination of capacitors. So that's it for this particular module. Thank you.